happy Saturday. Wait, no, Sunday, everybody. And I changed my time again because I didn't like doing this in the afternoon on Sundays just because I need to get stuff done. So back to 8 p.m. Sorry. Playing around with audio settings still, so hopefully this music isn't too loud. But as you can tell from the title, we're gonna go over HL paper 2, which, you know, I did SL paper 2 the other day, so we might as well finish it off, and then I'll probably look into something IB or AP related for Thursday. But anyways, let's just get started. So paper 2 is calculator, and then this question looks familiar. But let's see. You have a circle, you got a radius of 4, an angle here. Oh, I did this question. Didn't this happen last time too? I think so. Oh well, for the sake of, you know, starting fresh, I'm just gonna work through this anyways. Because, you know, if you've ever seen something where they just tell you to refer to another video because it's been done, instead of just doing it again in the video, it's really annoying. So I'm just gonna go through this real quick. And I think I even did some of it wrong last time, so might as well just do this again properly. Why are you marking my test? Don't worry about it. So let's see. Find the value of theta given all of this information. So of course we know that this is 4. So what we're going to do is we're going to use cosine law, or cosine rule, where I'm going to take 4 squared plus 4 squared, and then I'm going to subtract 5 squared divided by 2 times 4 times 4. Let me just double check that that's actually the formula that they want. You know, there's so many damn formulas in math, and I hate it when kids are like, oh, you don't know this one off the top of your head? It's so annoying. Like, no, I don't memorize arbitrary formulas. I mean, some I use so often that, yeah, I'm forced to remember them, but here you go. Personally, I give formula bugs because, well, I don't expect you guys to, again, arbitrarily remember stuff, but oh well. Some teachers don't, and then that sucks. Okay, so we will take the inverse cosine of all of this thing. We want it in radians, and I remember that was an issue last time, so make sure I'm in radians, which I am. Okay, so inverse cosine, and then this is going to be 16 plus 25, oops, plus another 16. So 4 squared, of course, is 16, 5 squared is 16. And then divide this by 2 times 8 times, wow, can't talk today. 2 times 4 times 4, which is 8 times 4, which is 32. And I messed up my input. Great. Okay. Once again, so 32 plus 25 divided by 32. Did I mess this up somewhere? Oh, this is supposed to be subtraction. Jeez. Do you want to ping teams? No. I don't know, you go tell people if you feel like you want more people in the chat. I'm okay with it being a little died down compared to when I first started. Here we are. Okay, so this is your angle in radians. So there it is. And then we need to find the area of the shaded region, so that's just the area of the circle. Subtract the area of the sector right here, which is 1/2 pi times the radius squared times theta, which luckily I still remember from last time. Okay, let's put this into a calculator again, and we're done our first question. Times 16 times 1.35. There you go. So 16.33. Centimeters squared. Okay, done this question, which I already did last time. Number 2. This one looks like a question I did last time as well. That's fine. Okay, so investing again. 5.5% compounded quarterly. This is annual interest rate. And then follows a geometric sequence, common ratio R, giving your answer to 4 significant figures. Okay. So we use our formula. And then I forget the actual values, but like the variables in the formula. But it's something like this. So these letters may or may not be actually these in your formula book, but that's okay. Anyways, but we want to find a common ratio given that her money every year at the end of each year follows a geometric sequence. So what we should do is we have our first year of money, which is P, and then we should find her second year of money, because then that's the first 2 terms of a geometric sequence. So let's see what we get. So I'm going to call it year 2. And then this is, of course, the money in year 1, which is P. And then all of these things are given to you. $5.5 times 4, and then the amount of years that passed is 1 because, well, I'm finding the next year. And then this whole thing is the geometric ratio R. Which is what we want to find out. So I'm just going to calculate this in the calculator. And I said this last time, and I'll say this almost every time there's like a calculator focused exam. I hate them. It like makes students rely on them a bit too much. I mean, they're useful, but like generally that just means they just give you ugly numbers that don't necessarily work out. Thanks, plate of kimchi. So here we go, 1.06. IB is 3 sig figs. So this ratio 1.0. What did I even say? 6. And then Lori makes no further deposits or withdrawals from her account. Find the year that this will be doubled. So taking this formula here, we want to find out when we have doubled our investment. So our future value is 2p compared to our initial investment, which was p. And then all of this stuff was going to be 1.06 to the power of t. What does Max say? In my opinion, if you don't understand the concepts, you shouldn't be allowed to use a calculator. Yeah, and I think that's why IB tests you in 2 different exams. You do have a calculator exam, and then, but that's the second one. The first one is the without calculator, right? So you really need to understand your concepts, whereas like calculators just kind of cheat you through the math, and it kind of like lets the examiner ask unreasonable, well, not, I don't want to say unreasonable, but they let you ask numbers that aren't going to work out compared to if you had one in a non-calculator section. Like, those have to be easy numbers. Anyways, where was I? So p's will cancel. So essentially, we're just solving this easier one. 2 equals 1.06t. And then there's lots of ways we can do this. You know what? I did a graphing last time. This time I'll use logs. So t is the log base 1.06 of 2. So let's see if this calculator can do logs in more than one base. And it might not. Oh, I think it does though. Okay, so log 1.06, and then inside of this we got 2, and then 11.9, let's say. So this is 11.9 years it will take. And then just always make sure you're answering the question. They want to find out what year this is happening, and she started investing in 2020. So 11.9 years later is 2031.9. But essentially, it's, I went over this last time, but what year is it going to happen? It's going to happen in 2031, later in the year, but it does happen. So here's your answer. I think the number looks a little different than last time I did it, but I feel like this is more or less a method that is correct, that you can do. But honestly, this isn't the same number that I got last time, which means that I did something wrong, but that's fine. Probably rounding error or something along those lines. And then this is something else that someone mentioned to me, is they were like, oh, why do you keep messing up? Like, aren't you supposed to know this math? And yes, I am, but you can, like, if you just even bothered watching, you can tell that I know what I'm doing, except like, I'm doing this just YOLO. I'm not doing any like prep in the background. I'm not looking at these questions ahead of time or the answer key. So, you know, that leads to some errors. But if you notice, the math is correct. Well, the process is. Maybe the numbers are off. I don't know. So let's see. This one I also did. Okay, whatever. We have a 6-sided die, but it's biased in a way that getting a 6 is not 1 out of 6, it's 7 out of 10. And then we throw it 5 times, and then we need to find the probability that we get at most 3 6s. YOLOing math, so cool. I mean, I guess. let me set this up first before I explain how I do math when it comes time for like me in school. Okay, so notice that basically this is a binomial distribution. We are counting the amount of sixes, so here's the probability of we're counting the amount of sixes, so here's the probability of 1 6, and then we're doing this over multiple trials, and then we're interested in, you know, how many show up in that amount of trials. So in this case we have at most 3 sixes. So basically I need to add up these probabilities together. In 5 trials, the probability of getting 1 6, the probability of getting 2 6s, the probability of getting 3 6s, and then there's always the last one that people forget, the probability of getting no 6s. So you can calculate each one of these individually, but of course, because we are adding up, you know, a successive amount, then there's a more efficient function in your calculator called Binomial Cdf, which is cumulative. And this is what we're going to use in the calculator. Oh man, I have this terrible habit of like closing the calculator application after I finish using it for a question. But anyways, this is in stat calc, I think it was. Nope, it wasn't. Quit second, and then you want distribution. And then binomial CDF, and this was 5 times, so 5 trials. The probability of each trial being a 6 was 7 out of 10. And then we are interested in up to 3 6s in the 5 trials we have, so my x value is 3. So paste this in, and then you get your answer, 0.472. So anyways, I tell this to my kids all the time, but I don't like spending a lot of time on math if I don't have to, especially during a test or an assignment. So I do things as fast as possible, especially in high school where, at least for me, things were pretty straightforward. So I would do a test and probably do it anywhere between, I don't know, 10 and 20 minutes. And, you know, obviously I'll double check it afterwards, but then I was more for speed than for perfection. Mostly because I knew regardless, my math was good enough that I'd get over 90. And I just don't, personally, I don't get the people that stay until the very end. Because, I don't know, you're just stuck in like your own brain thinking about the same things over and over again. And I'd just rather, you know, finish it ASAP, because the mark is going to be good enough for me. Anyways, let's find the third 6 on the 5th toss. So there's a lot to unpackage here. The third 6 on the 5th basically means that you need 2 6s in 4 trials. So basically, we need to find out the probability that you roll 4. Oops, not 4. You need to roll 2 in 4 trials. And then this needs to be multiplied by the 5th dice roll, which needs to be a 6. Because they tell you it needs to be a 6. And luckily enough, we do know what the probability of getting a 6 is. So 7 out of 10. And we can just put this in a calculator again. So this time I am trying to find a singular probability for a singular count of 6, like 2 of them. I'm not adding up different instances of different results of 6s. So what I can do is I can use just regular binomial PDF, which is the probability for one instance of your whatever you're interested in. So this is 4 trials now. The probability of getting a 6 stays the same, and I'm interested in getting 2 of those. So here's the probability of that, and then I need to multiply this by the third 6, which was 7 over 10, so 1.85. Or 0.185. But so far, these questions have been also appearing on the SL. I didn't realize that there's going to be this much overlap. I think this one is also one that I did from HL. Okay, we have a table of data of x's and y's, and then we need to make a regression. And the only tricky thing is we want a regression of x on y. Now typically it's like traditionally the other way around, so just be a little careful when you're choosing your stuff. So you go into second and list, oops, quit. You go to stat and then you can press edit, number 1. And you can see I did this last time, so the lists are still here. List number 1 was the x's, and then list number 2 was the y's. And we go back to stat, and then we go to the calculator section, and we want a linear regression. And then you have to be careful, the x list is the x, well, it's, I don't want to say this, it is this variable. The x's and y's are switched, essentially. Hello, plate of kimchi. So we want this one to be list 2, and then we want the y list to actually be list 1. So make sure you choose the appropriate ones. And then here you go. Here's your A and B values, which is what we want to find out in part A. So A was this, and then B was negative 10 point something. 10.4. Can I go over homework? I can. Do you have a specific question? If you do, then type it in the chat. You want your feedback? Yeah, that'd be nice. I would like to have your feedback too, but I don't. All of them. I gave you the answer page at the back of the assignment though, Kimchi. So as long as you're matching them, then you're right. Okay, meanwhile, let me move on. And then we have, so that's line 1, is we make this regression of x on y. And then there's line 2, which we make the regression of y on x. Anyways, Kimchi, check the answer key. And then if there's one that's off, then maybe ask that one in chat, and then I can go over that one specifically. But, like, you understand the lesson, right? And then, back to this one, the 2 regression lines, they will intersect through the same spot with coordinates P and Q. And then the thing you need to realize was the shortcut to this is both lines go through the mean of these values. That's a kind of part of what a regression one of the qualities of a linear regression is it goes through the mean of the two values. And so what we can do is calculate them. So if you go back to stat, and then we have two variables, so we go to two variable, we can calculate each mean. So you see, here's the mean for the first list, and then the first list was the second list in my computer or calculator, and the second list is the y of the question. So that is, so the q value, which is the y value, which is the x value in the calculator, is 30.3. Whereas the other one is going to be lower, right here, 28.7. And then, oh, this one is new for HL. Jennifer was absent for the first test, but scored 29 marks on the second test. Use an appropriate regression equation to estimate her mark on the first test. Okay, well, we have this formula, and then 29 marks is her second test, so that's the y value. So we can just plug this into here to try to make a regression on what her mark on her first test would be, and we already know what A and B are going to be as well. So 1.29 times the y value 29 minus 10.4, so 27. Okay, let's hope that I actually get some new HL specific questions. I do not, because this one I did last time as well, but that's fine. In case you don't want to actually go and watch the last VOD, go through it here. So we have a displacement, and then we want to find the maximum distance from the origin. So what we can do is we can just graph this and then find the minimum and or maximum value of the function. So this is x squared cosine x plus 2x sine x. And then let's change my window. The domain is from 0 to 5, so I'm going to go from 0 to 5. And I feel like I'll change the maximum y value to be 10. Okay, it goes to a little bit lower than that, so let me change this to 20. Okay, so the maximum distance away from the origin would be the value of the function that is the furthest away from the center here. So this one is going to be the most that this particle will be from the right of the origin. However, there is a greater distance that the particle is to the left of it. So we need to find this. Okay, so what we can do is we can quickly calculate the minimum value. And then for TI-84, you need to select your boundaries. So a left bound, a right bound, and then a guess. So this y value, negative 16.5, is how many centimeters it is to the left. So the maximum distance is 16.5 centimeters. Okay, so sketch the graph of each line, 2x plus 1. So the way that we started, because this is just the first assignment, is I told you guys to use a table of values. Because we're going to learn shortcuts to this later. So we have y equals 2x plus 1. So tomorrow we're going to learn how to do this without a table of values because this takes too long. But for now you need to know what a table of values is. So basically, you get to select your x values. And if you don't know anything about the graph or where to start, then I recommend, like 0, 1, 2. And then what we need to do is we need to put each one of these numbers into the formula for y. So for example, this one, the formula says it's 2 times x plus 1. So here's 2 times x. Now x is 0 for this particular case. So I do 2 times 0 plus 1. You do the math, and this gives you 1. So that means that there is a point of 0 and 1, because this is the x value, and this is the y value on the line. The equation for this line is this, and then we use the equation to get this point. So now, before you do the other ones, you can put this point on the graph, and it should be somewhere right here. And then we continue. So now we do the exact same thing, except now my x value is different. It's 1. So the formula says to get the y value, I do 2 times 1 plus 1, which gives you 3. So this gives you a second point at 1 and 3. X value 1, y value 3. So then on your graph, you can add that point. And then one more time, 2 times the x value, which I decided is now 2, plus 1. So this is 5. So we have our third point, which is at the x value 2, y value 5. You add that to your graph, your grid, and then you connect the lines. You get the point. And then that's basically how you do all of those questions. Make sense? Okay, and then let's see. Find the acceleration of the particle at the instant it first changes its direction. So changing direction, well, here is our distance graph, right? As a rough sketch, it went like this. And where it first changes direction is, notice, let me change color so that you can see that this is an axis. If your distance graph is above the x-axis, then you are to the right. And you can see that if you follow this graph the way it is, you are moving towards the right up until our very first maximum point. And then you get closer, so this means that you change direction right here. Because here's what I'm thinking. To get the acceleration, what we got to do is we need to find the second derivative. And then we just plug in the time. And then that time is the time that it first changes direction. So I need to find out what this is. So there's two things we need to do. First one, I'm going to find this time. So we go to our graph. And I need to find out this part. So we can just second calculate the maximum value. And then again go through the parameters. It wants a left bound. It wants a right bound. And then you make a guess. So here's where my maximum will be. And then this is where it first changes direction at 1.52. When am I ending my stream? Whenever I finish this exam, which is probably around 10 or so. Maybe a little after 10. So now that I have the time, I now need to find the second derivative. Or at the very least, I'm actually going to find the first derivative. Because your calculator can calculate the value of a derivative given what t, I guess, in this question, what t you're going to be plugging into it. So unfortunately you can't find second derivatives, I think, but it can find first derivatives. So I'm going to find this first. So, man, I really can't talk today. So what I'm going to do is take the derivative of all of this stuff, which is pretty straightforward. So a little bit of product rule. So here's the first term, and then we need to take, again, a product rule, the second term. So that's 2 sine t, and then plus 2t cosine t. Alright, so now that I have this, see, I can calculate the derivative of any given function. So my variable is x. And then I just put all of this in. So 2x cosine x minus x squared sine of x plus 2 sine x plus 2x cosine x. And then I want to evaluate this at my change in direction time, which is 1.52. Why is the second term in the second part of the first question you did in this stream multiplied by pi? Let me come back to that. Let me finish off this question. So negative 8.92. So here's my acceleration, negative 8.92 centimeters per second squared, I think. So the first question in the stream, second term in the second part, this one? Is this not the formula for an area of a sector? Are you talking about this pi? I pulled this off the top of my head after I gave a little rant about memorizing memorizing arbitrary formulas. There's no pi? there is no pi. Okay. Delete. So this is a little off. Like I said, not a big deal. Okay, 16 pi minus 8 times 1.35. 39.5. Okay, we've had like 4 SL questions in a row. This one's gotta be HL. Yeah, probability distribution. Okay, so X is the number of passengers who ride a taxi. So I guess given any taxi, this is the probability of how many passengers are in that car. And then after opening up a new highway, they charge a toll, and then it costs money. Well, it doesn't always cost money, whatever. $2.40 per taxi plus $1.20 per passenger. T is around $1. And then we need to find the expected value of T. Okay. So what we need to do is we need to find out how much it's going to cost for each group of passengers. So for the first passenger, it's going to cost $2.40 plus $1.20, which is $3.60. So I guess I'll call this little t. And then for each passenger more, we add $1.20. So the next one's $4.80. Then 6, $7.20, and then $8.40. And then to find the expected value of the cost, we multiply the cost for each ride with the probability for each specific ride. So put this all in a calculator, I guess. So 360 times 0.6 plus 480 times 0.3 plus 6 times 0.03, 720 times 0.05, and the last one, 840 times 0.02. So expected value of the cost of the taxi is $4.31. Okay, then given that you know the variance of the passengers, find the variance in the cost. Well, we know how the cost and the variance are related. It's $2.40 plus $1.20 per passenger. So if you want to find the variance of this is essentially the same as finding the variance of this. Adding a constant amount doesn't affect the variance, so essentially I just need to find the variance of 1.2x. So according to your formula book, I'm pretty sure they tell you how to calculate changes in variance. Right here. Oh, it does affect it. No, it doesn't. I was looking at expected value right here. So we just square the a value. So this is equal to 1.2 squared the variance of x, which is something that they tell us right here. Alright, then back to your calculator. 1.2 squared times 0.8419. So here it is, 1.21. Oh, so you know what's funny? As I was talking to one of my students who was doing their HL test, and then I was comparing it to SLs. So an SL, AASL, you are given 90 minutes to complete 80 marks. So essentially you have a little over a minute per mark, 1.125. And then I thought, well, because HL is harder, then the ratio will be more generous. And it turns out that it's not. You have 2 hours, 120 minutes to do, I think, 100 marks. Or was it 110? We can check that right here. 110. So you see the ratio is worse. I feel for you, HL students. So 120 divided by 110. Yeah, you still have a little bit over a minute. Barely. You have 1 minute and 5 seconds per mark. So I'm just going to round this down to about 1 minute. That sucks. I thought you guys would have a better ratio because you were doing harder stuff and there's more of it. But it turns out you have less time. Anyways, let's see what this next question is. We have 2 ships from an origin, and then here are their position vectors. And then the distances in kilometers. Find the minimum distance between the 2 ships. Okay, so let's first find out the difference between them. So RB minus RA, which is 4 over 3 subtract 7 and negative 3. And then 0, 12, subtract 5 over 8. So 4 minus 7 is negative 3. 3 plus 3 is 6. And then 0 minus 5 is negative 5. 12 minus 8 is 4. Okay. So this represents the difference between them as a vector. So if we calculate the length of this and then find the minimum of it, then that should answer our question. So first let me change this into parametrized form. So the x value is going to be negative 3 minus 5t. The y value is going to be 6 plus 4t. And I need the x and y components because, well, it's just easier to calculate the distance because it's just Pythagoras on these. then we want to minimize. And then, you know, a calculus student's jerk instinct when they see the word minimize is, you know, take the derivative, find the critical point, go through the first derivative test. But this is a paper 2 and we have a calculator, so I'm just gonna graph this and find the minimum value. So -3 minus 5x squared plus 6 plus 4x squared, close this to the power of 1/2 for the square root, and then graph. And my window is completely off. So let me change this window a little bit and see if I get a better picture. Okay, I need to change my window a lot. Is this just increasing forever? Okay, I'm gonna cheat. In the sense that I'm gonna go Desmos. Just because it's way easier to play around with graphs. Plus 4t actually I should change these to x's. Okay, well, oh, no wonder, I was on this side. But you can see there's going to be a minimum right here at this x value and y value. So the minimum distance is the y value, 2.81. And then, ooh, complex question. Okay. I have two complex numbers, z and w. They satisfy these equations. And then I need to find z and w in Cartesian form. Okay, well, this is a system. And it seems the easiest thing that we can do is make a substitution. So w is going to be 2I times z. So we can substitute that into the second equation. So we have z star is equal to 3 times 2I z. And then this is equal to 5 plus 5I. Okay, and then when you're trying to solve a straightforward complex equation and it's in Cartesian form, then you should write your variable in Cartesian form, and then what you do is you just compare components, real and imaginary components. So that means that z complement is minus, and then this thing is going to be negative 6I times a plus ib. And then multiply this thing in. So let's see, the i's and then the minus are going to make a positive 6b, and then we're going to have a minus I6a. And then this is equal to 5 plus 5i. Okay, so if we compare our real parts, then a and 6b need to be 5, whereas minus b minus 6a need to be positive 5. So we have a plus 6b equals 5, minus b minus 6a equals 5. Okay, and then we just solve this equation. Let's see. I'm gonna multiply this by 6. So I get, well, and then rearrange this so everything lines up a little better. And then I add these equations together. And I can't change color right now, whatever. 35, 35b. So b is 1. That's nice. And then we can go back and then calculate a. So if a plus 6 times 1 has to be 5, then a has to be negative 1. Okay, so z is negative 1 plus I. And then this implies that w, which is 2i times z, is 2i times negative 1 plus I. I'm just double checking that that was it. So what do we got? Negative 2 minus 2i is w. Not bad. And then, okay, some more short questions. Okay, consider these two graphs. Find the set of values where they do not intersect. So this part right here, no intersection point, to me really signals that I should be using a discriminant. Because, you know, things that have to deal with existence, such as the existence of no intersection points, is generally we can come back to a discriminant. So let's see, if I make these two things equal, and then we'll see what happens. So x squared over x minus 3 is equal to m x plus 3. Multiply this over here. So I'll get x squared is equal to m x squared minus 9. There are difference of squares, so we can just multiply that easily. And then let's collect things together on one side. And then let's just factor out the x squared. Okay, and then you can see we want to solve this quadratic equation for no x-intercepts, which is essentially the same as saying no intersection points. And so, well, we just use the discriminant. Here's our a, here's our c. We don't really have a b value. And then our discriminant is b squared minus 4ac. And we want to find out when this is negative. So minus 4, 1 minus m times 9 was less than 0. Wait, I did something not quite correct here, or... Okay, make these equal, multiply, move over, factor. No, it seems okay. But this looks suspicious. Oh well, we'll keep going. So we have negative 36 plus 36 m needs to be less than 0. So m needs to be less than 1. Sure, okay. That seems okay, I guess. How many points is this worth? 5. Maybe I'm overthinking things. Oh well. We'll check the answer key later. Oh, okay, long questions. Okay, this one looks familiar, so try not to spend too much time. We have a length of a seashell normally distributed with a mean of 25. And we don't know the variance. And then the probability that it's less than this length is that probability over there. So 24.15. We have this. This song is weird. Okay, next we need to find the probability that it's in between 24.15 and 25. So we know the distribution from the left side to the mean is 0.5. So I'm just going to take 0.5 and then subtract 0.1446. And then that's 3,554. And then hence find the standard deviation of x, so we will need to do some standardization using this information right here. So first off, the z-score is 24.15 minus 25 divided by the standard deviation. And then we can also use the z-score by doing an inverse norm. So we go to our distributions, we go to an inverse normal, and then it's the same area, of course, but when it's standardized, we know the mean and standard deviation, so we can calculate the z-score this way. So negative 1.06. Alright, so then from this equation for the z-score, we can find the standard deviation by dividing these two. So 24.15 minus 25, divide this by negative 1.06. So 0.802. Yeah. Okay, and then hence find the probability that a seashell selected at random has a length greater than 26 millimeters. So once we have everything, that's easy to do. We just put this in a calculator. So second distribution, normal Cdf, and our lower bound is the 26 millimeters, our upper bound is whatever, so just make sure that it's reasonably large. Our mean was 25, and we just found out our standard deviation. So here we go. 0.106. And then a random sample of 10 seashells is collected on the beach, and let y represent the ones that are larger than 26 as imperial things. Or is that just imperial with z's around it? Like, you know, the classic underscore xx, like Sep P. Roth 69 underscore xx. Love those usernames. Alright, and then we want to find the expected value of y. So the expected value of y, well, there's what, 10 seashells? And we are trying to find out how many of these on average are going to be larger than 26. So we multiply that by the probability of each seashell being over 26. And if you pull out a calculator for this one, then I would be very embarrassed for you. 1.06. And then, let's see, find the probability of exactly 3 of these seashells having a length greater than 26. So, probability that we have 3. But this is a binomial distribution, right? We have 10 seashells. Those are our trials. We are finding out what's the probability of having 3 of them, given the probability of each trial. So second distribution, scroll down to the binomial PDF, 10 seashells, the probability of one seashell being over 26 millimeters, and we are interested in 3 of them. So the probability of this happening, 0.0652. And then last one, now we choose a random seashell, which has a length less than 26. Find the probability that it's between these 2 lengths. So this is a conditional because they did tell you something that happened. So we want to find the probability our seashell is in here, provided that we know that it is less than this. So we do have a formula book for this. So we can just use it. I don't want to write this again. Paste. And then intersection here. Okay, and then we more or less know both of these values. Being less than 26 is the probability of 1 minus being more than 26, which we found out earlier was 0.106. And then this top one is a very elaborate way of saying unselect, please. Of just saying this part. Because if you think about it, the intersection of these two, here are all of the values that are less than 26, all of the seashells less than 26. But within this, these are the seashells that are in between this specific value. So their intersection is just the probability of being within these two values itself. And that we found out in part A. So we can just calculate this. So 0.3554, we're going to divide this by 1 subtract 0.106. So there you go, 398. 0.398. And okay, so last two questions, but I'm sure these will take a while. So let's see, we have a large tank that has water. Water is gonna flow, salt is gonna flow into the tank, and then you stir it, and then you shoot some out at the bottom. So X is salt, T is minutes, and then the rate of change of the salt in the tank is here, which is described by this. Then we need to show t plus 1 is an integrating factor. Oh man. Okay, well, let's go open our formula book and then go down to the integrating factors, which is here. So if you ever have a differential equation in this format, then the integrating factor will be this integral. So let's see if we have that format. So I have essentially, how do they want to write it? Okay, let's call this x prime. And then if I move this one over here, so to find the integrating factor, I take e to the integral of p of x. P of x is the coefficient of y. In our case, the coefficient of x. So p of x is 1 over t plus 1. Therefore, our integrating factor is e to the integral of 1 over t plus 1 dt. So this is going to be the natural log of t plus 1 Nothing fancy there. And then because we have e to the natural log, these essentially cancel out, so we get t plus 1. So there you go. We have shown t plus 1 is an integrating factor. Hence, by solving this differential equation, we show x is going to be this. Okay. So, now that we found out that this is the integrating factor, essentially, we are able to solve this. First, we multiply everything by the integrating factor. That's one of the things you need to do. And to be honest, I don't 100% remember this procedure, but we're gonna see how it goes. So once we're here, you gotta do something with it. Maybe I should have reviewed. Hold on. Let me just quickly look at how integrating factors work. But remember what I was saying earlier, how I just kind of jump into these and I don't do any background knowledge or background prep? Sometimes this happens. It's not a big deal, I guess. Let's see. Integrating factors. So, yeah, you're just supposed to memorize an equation. Integral of I cubed divided by I. I guess this goes in with what I'm doing. Imperials, you're doing a good job helping out others with math. Thanks. Wondering if you stream every day, because I got finals and I will definitely need help. I don't stream every day. I have a schedule. It's, for now, mostly 2 times a week. Sunday around 8 I start, and then Thursday around 8 Pacific time. Some days I might do Tuesday. Again, this is just me doing this for fun. I'm an actual teacher, so I got my full-time job. But when do you have your finals, Imperials? And what kind of math are you doing? I have functions and finals in 2 weeks, so you have possibly, what, 3 to 4 streams, at least my streams, if you need help. And I stream for anywhere between like 2 to 3 hours. And kind of the format of this stream is, if I ever do get busy, then people just keep asking me questions in chat, and then I'll be going over them here. But because, you know, it's a small stream and I don't have a lot of questions right now, in between questions from chat, I just go through old exams. In this case, I'm going through an IB one. So, you know, if you catch me, or even right now, if you have a bunch of questions, feel free to ask. Or whenever you tune in. Okay, so here is the formula, if you know what the integrating factor is. So we need to integrate this top bit, and you know that it should turn out to be this. Yeah. Because of COVID, I can't do much else. So I just decided to start streaming, and you know, no one cares about me playing video games, at least because there's thousands of others. So here's my niche, which is helping out people with math. So let's see, probably an integration by parts I'm going to do for the top. Mostly because if I take the derivative of this, or integral of this, it's more or less the same. If I eventually take enough derivatives of this, it should go away. So let's see, I'm gonna say dv is this part, and u is this part. So of course du is going to just be dt, nice, and then do this one. No questions? Yeah, come on by. Have a good day too, Imperial, if you're heading out. And then I need to find out what v is. So I know that it needs to be the same exponent because it's e. And then when I chain rule, I should get a thing of 10. And I'm going to be multiplying by... So if I try to integrate this, this needs to be the same because it's e. I need a coefficient of 10. And then that results in taking this coefficient, multiplying it with the chain rule of this, which is -1/4, or negative divided by 4, so -40. Okay, and then let's see what we get from here. So u times v, which is t plus 1 times -40e to the -t over 4 minus the integral -40 et over 4 times du, which was just dt. And then, does this show up in the answer? And it kind of does. So it looks like I'm heading in the right direction. I'm going to leave this as it is for now and deal with this integral. And following the same process, 160 plus c. Always remember your plus c if you're doing an indefinite integral. Can you go over my last test question about the proof? Sure, in a bit. Let me finish this off first. Okay. So it looks like we're almost there. We need to find out what the constant is. So there needs to be some information the question gave us about x. So again, x is the amount of salt in the tank, and then initially there's no water. So in other words, I know that x of 0 is 0. So I can plug this in and then solve for c. So let's do that then. So 0 is equal to 0 plus 1, which is 1. This is 0, so this is just going to be negative 40. Yeah, so this is 1. This is 0, so that's 1. So that's negative 40. Again, same thing, so this is just 160. And then this is all divided by 0 plus 1, so divided by 1. So here's my equation. So my c value is 200. And then I think all we need to do is just make it look like what the question wants us to make it look like. Because it's not quite in the right order or factored in the right way. So there's a 200, and then I factor out a 40e to the negative t over 4 from these. Honestly, we're basically done, so let's just call it there. Max Seam, go over your test question. Let me see if I even have it with me. I'm pretty sure I do. But I don't know, I might have just also left it at work. But I have a feeling it's here. Yeah. So, a little sidetrack. Using the mathematical induction, that one. I think that's the only proof one I asked. Okay, so the question is, use induction to prove the following statement. The sum from 1 to n of r times r factorial is n plus 1 factorial minus 1 for natural numbers. Okay, so for base, we need to do our base case, which is n equals 1. So on the left side, we have 1 times 1 factorial, which is just 1. On right side, we have 1 plus 1 factorial minus 1. So this is 2 factorial minus 1. 2 factorial is 2. 2 minus 1 is 1. So we know that our statement P of n, well, P of 1 is true. Okay, then we assume that this statement is true up to some arbitrary k value. So in other words, this thing is true, with a little bit of modifications, of course. So this is, on the left, the sum from k, 1 to k. And then over here, the n value is now k. So we take this as a fact because we're assuming this is true. And then now we try to prove the case where for k plus 1. So this is from 1 to k plus 1 now of this. And then we need to somehow prove that it's going to be, you know, this thing, but with k plus 1 here. So what we need to do is we do need to use this statement from previous in our assumption. And the way we do that is you got to remember your sums. The sum from 1 to k plus 1 is the same as the sum from r equals 1 to k plus the extra term, which was when r is k plus 1. Like that. And then on this part, we can use our inductive thing, this. So we could just make a little substitution. Right here. And then what we want to show, of course, is we want to show that this statement is true for k plus 1. So we want k plus 1 plus 1, which is k plus 2, minus 1. Okay, so then we just play around with this. We need, here's our minus 1, probably, from the proof. And then we need to combine these two terms together. So they do have a common factor, so that's what I'm going to do. And then do a common factor of k plus 1. And then it more or less is done, max. So k plus 1 factorial common factor. And then this is just going to be 1. And then you have this one, which is k plus 1. Yeah, you better see it now. And then of course this is k plus 2. So then k plus 1 factorial times k plus 2 is, by definition, k plus 2 factorial minus 1. And then this is the right hand side. So we're done the proof. Yeah, it feels bad, man. Doesn't it suck when you get stuck on a question and then the teacher just explains it and it seems so easy afterwards? But you know, like I always say, that's why I'm at the front of the class and you're not. Yeah, I'm sure you made a mistake. Okay, where were we? Okay, so this is basically done. You can go through the algebra. Essentially, you just take a common factor of 40, well, minus negative 40 e, blah, blah, blah. And then it will probably simplify into this. So I'm just gonna copy. Oh, can I copy this? I'm gonna copy this so that I can use it down here, because we're probably gonna use this to do some like integration or something. Okay, sketch the graph of x versus t for 60 seconds. Find the maximum amount of salt in the tank. Yeah, oh well. Well, this is just a graphing question, isn't it? So exciting. You're gonna go play Minecraft? Okay, bye. So let's graph this. And then where is E? Here. Yeah, you better leave the stream open. And then I hate calculator questions. Okay, close this, divide this by t plus 1, x plus 1. Change my window because they specifically said between 0 and 60 seconds. And then let's see what's going on here. So here's my graph, and then I want to find out where the most salt happens, and this is a graph about the salt. So calculate the maximum. So left bound, right bound, make your guess. And then what does the question want? Sketch it and find the maximum amount. Oh, okay, well, do your sketchy. The maximum happens at 6.6 and 14.6. Is tomorrow really Monday? It depends on what time zone you're in. Some people, tomorrow is Tuesday already, because today is Monday. Alright, find the value of t which the salt tank is decreasing most rapidly. Okay, well, we want to find out when the rate of the decrease is the biggest. In other words, I need to graph the rate, which is right here, and then find the minimum. Otherwise, you'd be having to do some calculus. But again, when you're doing a paper 2 and they ask for minimums, maximums, I would probably never do calculus. Unless it was somehow faster. So 10e negative x divided by 4 minus x divided by wait a minute, this x is not the same. Oh no. I need to plug this thing in for this x. This sucks. Okay, well, here we go. So 200 minus 40 e negative x divided by 4. Well, it's not that bad, but still. Plus 5. Bracket, bracket, and I'm dividing this by t minus 1 and then another t minus 1. So t plus 1 squared. Alright, and then let's see what this looks like. Can't see anything. So let's change the maximum to 0 and change the minimum to negative 100 just to be safe. Window range. Where's my graph? Did I not put it in right? Man. Okay. Seems like I did. Maybe negative 100 is too much. Let me just change it to 20 and be reasonable. Oh, there it is. Oh, so small. I don't even think I need to go to like 3. Let's go to 2. Yeah, there we go. Okay, second, calculate the minimum. Left bound, right bound, make a guess. Okay, here's my minimum, and so I want to find out what value of t. That's my x value, so that's at 12.9. Question D. This question's taking forever. What's this one? Last one? Okay. The rate of change of the amount of salt leaving is this. Find the amount of salt that left the tank. So this is the rate leaving, and then I want to find out how much has left. So, don't I just integrate this? I feel like that's too simple, but maybe the integral's ugly. Oh well, here we go. Calculator. So let's go to this. Now note what this is. The x divided by t minus 1. That was this part of the graph function. This part. So what I'm gonna do is I'm gonna delete this first term. So I have this. And let me just change the window to something a bit more standard. Okay. And I want to integrate this, which is a function in your calculator. Right here. And then your lower limit should be 0. Your upper limit is 60, which should give you all of this area. 36.7. And then I'm done. Okay, and then one more, right? Yeah, last one. That's a good amount of time. Been almost 2 hours. Helped out some people with math. My number of viewers has slowly declined though. But oddly enough, the views that my VODs have are like still decently high. So I wonder what's going on. Maybe people just can't make this time. Oh well, okay. Let's see this. Show that cotangent to theta is gonna be this. Okay, identities. Everyone's favorite. So cotangent to theta is by definition the reciprocal of tangent to theta. And there's a double tangent identity in your formula book. Right here. So it's probably just the reciprocal of what they want me to show, which is, you know, the whole point. So 2 tan theta. Okay, and then we're done because that is the same as showing that. Okay, next up, verify that these satisfy the equation. So so if I plug them in, they should just work, right? So let's try tan first. And then I need to show this is going to be 0. So I'm probably going to use part A and change this here. And yeah, everything seems to be working out. Nice. So you can see this 2 will cancel with that 2, this 10 cancels out with that 10, and then we have a 1 with a -1, we have a -tan squared with a tan squared, so nice, works out. And let's repeat the process with cotangent. Ooh, corner trigger. Let's see, I'm probably gonna use this identity again. I should just listen to the Chrono Trigger soundtrack. I need to erase. Hello? Is this gonna help me in any way? Oh, I need to plug in negative cotangent, so make sure that is happening. So what is this? Cotangent squared. And then this is just going to be a minus 2. This is 1/10, so then, well actually, okay. This is going to go here. Then I will have 1 plus 10 squared over here, like here. Okay. So what we're going to do is we're going to split this fraction up, because this part with the 1 is going to cancel with this one, and then this part is essentially 1, and that's going to cancel with that one, and then we get 0. And then, yeah, everything works. So we have shown and verified that these are solutions. Okay, and hence or otherwise show that the exact value of tan is going to be this. Let's see, how can I use what I know? I want to use this. Let me use the original version. So what I'm going to do is I'm going to take theta as whatever it was, pi over 12. So 2 times pi over 12 is pi over 6, and then this is nice because I can evaluate that. And over here I have my, this should be pi. Pi over 12 over 1 minus 10 pi over 12. Okay, I think I know what to do. This probably isn't the most efficient way, but it works. Okay, what is tan pi over 6? 1 over root 3. I think. Over 6. And then if I were to multiply this by 3, I should get the same number? It's not. Time to draw my triangle. Pi over 6, 1, 2, root 3. No, it is 1 over 3. Opposite over adjacent. Mode, radian. Wait, if I square this, I should get 3, right? Yeah, okay. No, it works. Okay, and then we're essentially trying to solve tan pi over 12 as a variable. So I'm going to take this denominator, going to multiply it over to the other side. So I get 1 over root 3 minus 1 over root 3 tan pi over 2. And then I'm essentially trying to create a quadratic in terms of tan pi over 2. So after I multiply this over here and then multiply the 1 over root 3 in, I'm going to take this and then I'm going to move it over as well. So I get minus 2 tan pi over 12, and then this is equal to 0. And essentially we just try to solve this. I guess using quadratic formula. It is slightly out of order though, so let's just be a little careful. That's A, this is B, this is C. So tan pi over 12 is negative B plus or minus square root B squared minus 4 times A times C. So plus 4 over 3 divided by 2 times A. Oh my gosh, and then I have to make this look nice. Make it look like this. Alright, okay. First off, change to multiplying by the reciprocal. And then 4 is 12 over 3. So this is going to be 16 over root 3. Okay, multiply it in. I'm sure there was a more efficient way to do this than how I did it. How many marks was this question even worth? 5. Okay. So let's see. I think we're done. Things will just fall into place. So there's my minus root 3. Which I think is part of the answer, right? And then the rest of this is going to be 2. So let's see how that works out. This cancels with that. And then root 16 is 4. And 4 and 2 make 2. There's a minus though, so something went wrong somewhere. Hold on. Plus minus plus minus. And then we have plus minus 2. Alright, so we need to make a choice, and then the choice is already made for us. It needs to be the plus 2. And the reason being is that if you had a minus, then your value would be negative, which doesn't make sense because we have an acute angle, so all 3 ratios should be positive. Of course, this is equal to 2 minus root 3, and you will probably need to justify this. So since Alright, so after justification, you get your full marks. I really want to see how they did it, because I feel like this was a little inefficient. Alright, and then last question. Using parts B and C, find the exact value of this. Give your answer in this form. So, part B says that we have 2 roots. And then, notice that we just add those 2 roots together. Since we're essentially, we're talking about roots of a polynomial or a quadratic, we can use Vieta sums. And we know what is this song? And we know if we add the 2 roots, this is the coefficient of the x term. So 2 cotangent 2, and then the angle is pi over 12. This needs to be equal to tan pi over 12 minus cotangent pi over 12. Twilight Princess? I don't remember this song at all. Hold on, I have a... I heard that one Corner Trigger song, so now I want to listen to some more of its music. Okay, and then we're trying to solve this thingy. So I know what this is from part C. It's root 2 over 3. Or 2 minus root 3. And then over here, I can easily calculate this because I know what 10 pi over 6 is. We calculated that earlier. It's 1 over 3. So this just becomes 2 root 3. So solving for cotangent, that's 2 minus 3 root 3, right? This goes over here, this goes over here, these two become this thing. Late stream? Not really. I'm finishing up, and it's been about 2 hours since 8. Yeah, I think this is it. Sealmaster U came in just as I was near the end, because I just finished the final question. But I'm gonna go through this and make sure that we are mostly right. Oh, and then for those that are... Yeah, it's normally at around 8. Hockey practice. That narrows you down to one person that I can think of. But anyways, some good news for those that are watching right now, or those that will watch this part. I think I've hit almost all of the requirements to hit affiliate. Except for I need to stream, I think 2 more days, just like any 2 days. I've hit the minimum number of hours, the average viewers, and the minimum 50 followers. So very soon I will become an affiliate, which is good news. I get, I think 1 channel emote, and then people can subscribe. Not that I expect anyone to subscribe, but you know, nice. Alright, let's see if this is any good. Don't worry, people will. Doesn't that cost money? It costs like $5, right? Alright, let's see how I did. Okay, 1.35. I got 1.35. 39.5. 39.5. Lucas helped me out here. I actually had a factor of multiplied by pi, so my answer was off. I think that's also why I was off yesterday. Twitch Prime? That'd be nice. I don't know how the money works. I don't even know if I'm allowed to talk about Twitch money, but whatever. It's not going to be a lot. And that's not why I'm doing this anyways. Okay, ratio 1.56. That's not even proper formatting. 1.6. That is correct. And then I have a feeling this is wrong. I did mention it earlier. I did it the proper way yesterday. Because it should be 2032, and I'm off by a year. Oh well. Okay, 0.472. I have 0.472. And then I have 0.185. 0.185. Negative 1.29. Or wait, is that negative? No, it's not. 1.29, negative 10.4. Okay. And then P and Q, 28.7, 30.3, and then 27, 27. Nice. Okay, Maximum distance 16.5, 16.5. Negative 8.92, negative 8.92. Expected value 1.59. No, 4.31. I have 4.31. 1.21. 1.21. .81 kilometers, 2.81 kilometers. Okay, let's see. Z should be -1 plus I. Z is -1 plus I, so that probably means that my W is correct as well. Yeah, it is. Looking good. Only one question wrong so far. I have a feeling this one is wrong. M is less than 1. Oh, I messed up. Shoot. So this one is a bad one. I forgot to multiply my M into the 9. Rookie mistake. So let's fix that real quick. So if I multiply the M in, this gets an M, this gets an M. So this is 9M. So essentially what you have is you have a quadratic in terms of M. And because this is a negative right here, like your leading coefficient will be negative 9m squared, with your two values at 0 and 1. Oh wait, this should open upward. Jeez. Okay, your leading coefficient is going to be these three factors together, which is a positive leading coefficient, so your quadratic opens up. The x-intercepts are between 0 and 1, which means your quadratic is negative valued in between these. So the answer should be here. Shoot. Okay, let's see. Moving on. 3554, 3554, 802, 802, 1.06, 1.06, my probability is off. I probably just put in the calculator wrong. We just want a binomial, right? Ten trials. Probability of a seashell. Value 3. Oh. Why did this give me a different number? Or did I just forget a 0? I probably just forgot a 0. Okay, 0.398, 0.398, so that's good. Okay, this was a show, so I showed it, so that's fine. This one was also a show, which I did, so that's fine. Part C was sketch a graph. So that's fine. And then the first actual one we can check is 12.9. So here's the graph. We have the correct values. So 12.9. So that's good. And then 36.7, 36.7. Okay, part A was a show. So I think I showed that fine. And part A was a show, part B was a show. And then, part C, this is what I wanted to, is also a show. So I showed it, but I was interested in how they wanted to show it. So that was question C. So these are the roots of this. So then you solve for x. Still going for a bit. I'm gonna finish up. I'm actually just checking my answers. Oh, and then they did it my way here. But either way, it's a show question, so I showed it, so it worked. And then the final one, which is 2, 3 root 3. Shoot, they have 4. Why is mine not 4 then? Okay, this is a sum, so then these two are equal. Oh, did I forget my Vieta formulas? Where is that topic 2? So it should be equal to the negative, and yeah. So let's quickly fix this. So this is minus, that's minus. This is minus. But that doesn't change the fact that this is a 2 and not a minus 4. Let's see. Weird. But overall, not bad. What, 3 questions wrong? This one's slightly wrong. The other one was in error. I don't think I get any marks though. And I had something over here. So 3 questions wrong. More or less done in the time limit. Obviously would be definitely done in the time limit if I was actually writing this. And I think that's more or less still a 7. So good job, me. Alright, well, I think I'm gonna call that. Thank you everyone who stopped by or will watch this afterwards all the way to the end. And yeah, look forward to me being an affiliate, which will be just a matter of time. I think after next week. Pretty exciting. But I'll talk to you guys all later. Have a good night.